Students, welcome to the next lecture of Z transform. In this particular lecture, we are going to see what exactly the definition for Z transform. So let's look at the definition of the Z transform. When we say we need to obtain the Z transform for, let's say, the x of n, this is what the sequence for which we want to get the Z transform. Let's say this is what the sequence x of n for which we want to get the Z transform. So x of n will have the Z transform indicated normally with the capital X of Z. So this capital X indicates the Z transform of small x. So n will be converted into the Z. So time domain sequence will be converted into the frequency domain. So for this, let's see this particular definition, what exactly it tells. The Z transform of the sequence x of n is defined by, so it is nothing but the simple definition of the Z transform, that x of z is equal to summation n is equal to minus infinity to plus infinity x of n into z raised to minus n. So here the point to be considered is this particular term, that is n is equal to minus infinity plus infinity. This is very important since we are considering here the bidirectional Z transform, means ranging from minus infinity to plus infinity. If someone goes for the unipolar or one-sided Z transform, then it will be simply counted from 0 to infinity. So that is what the unipolar Z transform. Right now we are considering the both sides. That's why it is considered as a bipolar Z transform. So it is n is equal to minus infinity to plus infinity x of n z raised to minus n. Now, in other words, if someone want to correlate the Fourier transform with the Z transform, so it can be simply obtained with the equation. Just put z is equal to e raised to j omega and see the effect. This is what the effect, and this is nothing but the equation of Fourier transform. So z will be replaced by e raised to j omega. So this will be z is equal to e raised to j omega. Similarly here also z is equal to e raised to j omega. So the overall equation will become x of e raised to j omega is equal to summation n is equal to minus infinity to plus infinity x of n e raised to minus j omega n. So this is nothing but simple definition of the Z transform. Let's proceed again with the same correlation between the two concept, that is the Z transform and the Fourier transform. This is what just now we have seen. Z transform and Fourier transform can be correlated with this particular equations. So here the equation is simply identified that Z will be replaced by e raised to j omega, and the further equation will become like this. So equation 1 is nothing but the Fourier transform of x of n, and equation 2 is nothing but the Z transform of x of n. Now let's see the next part, that is nothing but the region of convergence. So region of convergence is nothing but ROC. So to define the region of convergence, it is nothing but the region in which Z is valid. So the region in which Z is valid. This is what important term over here. We will see in detail with some of the example what exactly the ROC, how to get the ROC. Let's see the alternate definition for the ROC. For a given sequence, the set of values of Z for which the Z transform converges. It means mod of x of Z should be less than infinity, and it is called as a ROC, that is region of convergence. So that is what the main objective over here. This is nothing but the region, that is R, this is O for F, and C for convergence. Now in order to obey all these properties of the convergence, the next part is quite important, that is correlated with the definition of the Z transform. So x of Z is nothing but summation x of n z raised to minus n, summation ranging from minus infinity to plus infinity. So take the mod on both sides. Because of this particular condition, mod of x of Z less than infinity. So if we want to track out whether it is getting valid, so let's put it mod on the both side. So this condition will tell us that mod of x of n after splitting it and mod of z. Just put the values and it should be less than infinity. So that is what the necessary condition for getting the ROC. ROC is normally given with the statement that ROC is centered at the origin and consists of a set of rings. Now in the next lecture we will see further details of the ROC as well as how it affects to the stability as well as the causality of the system. So thank you everyone. Thank you very much.